The pressurized solution distribution system, referred to as the PSDS, is used in a hemodialysis facility for the mixing and distribution of sodium bicarbonate solution and the distribution of acidified concentrate solution to remote points of use where they are used in hemodialysis. Warning: the PSDS is not equipped with solution monitoring devices for conductivity, pH, or other chemically founded parameters. The operator is responsible for following the testing recommendations of the solution, chemical, or product manufacturer. Note: the PSDS is a solution distribution system and does not perform proportioning functions. Caution: if the PSDS is used in a manner not specified by the manufacturer, the protective features of the unit might be impaired. PSDS provides a semi-automatic mixing of a bicarbonate concentrate powder with water that meets AMI hemodialysis water quality standards and distributes this solution to the hemodialysis patient stations. The PSDS mix mode provides semi-automatic mixing of bicarb concentrate using a mix pump in a separate 100-gallon mix tank. Once the bicarb solution is mixed and verified to the concentrate manufacturer's specifications, the PSDS can be placed into a transfer mode of operation, and the solution is pumped to the 100-gallon distribution tank. This process is monitored by a flow switch that will alarm and indicate when the mixed tank is nearly empty. The distribution tank is also equipped with a high-level float switch to alarm and notify the operator if the tank is nearing full. Solution from the distribution tank can be distributed to the patient loop using a distribution pump. The operational pressure in the distribution loop must not be allowed to exceed the dialysis machine manufacturer's maximum pressure. Therefore, Marco recommends the use of pressure regulation at each point of use to prevent these issues. The PSDS is available in models that can control the distribution of acid concentrate from a bulk storage tank to remote points of use. The acid distribution pumps are located near the bulk tanks with controls centralized on the PSDS control panel. Features of the PSDS include a large 3/4 horsepower single-stage centrifugal mix pump that provides quick and thorough bicarb mixing, a polyethylene frame that eliminates corrosion, semi-automatic controls that allow ease of mixed tank fill, an enclosed tank system that prevents contamination, separate 100-gallon mix and distribution tanks that permit large multiple batch capability, the capability to mix an additional batch of bicarb solution during patient treatments without interruption, internal spray heads in both tanks to facilitate rinsing and disinfection of the bicarb mixing and distribution system, acid and bicarb distribution tank levels monitored with low-level alarms, remote monitoring capability, independent pump controls, and low-level alarms for up to 3 acid solutions. System alarms included to ensure patient safety and equipment protection. Easy-to-use wide-opening hinged lids on mix and distribution tanks. 3-way valve system at the distribution tank to allow loop flow to return to the tank or go to drain. Also allows for taking samples at the end of the loop. An optional ozone disinfection system is also available. The inlet water solenoid valve serves to shut off or to turn on the water supply to the bicarb mix tank, permitting automatic or manual filling. A panel-mounted flow meter with an internal needle valve allows for visual indication of tank filling, and it allows the user to adjust the water flow rate. Solution distribution system is provided with a 100-gallon mix tank used for mixing the recirculation in the mix tank to mix the bicarb powder into solution. This pump also transfers solution from the mix tank to the distribution tank. A flow switch is located on the outside of the mix pump to prevent damage to the pump. The flow switch will automatically turn the mix pump off during insufficient flow conditions. The pressurized solution distribution system is provided with a 100-gallon distribution tank used for distributing the mixed bicarb solution. The 1/3 horsepower distribution pump provides quiet and reliable distribution of solution to the patient stations. A remote monitor indicates the operational status of the PSDS system. It's used to alert nursing station personnel when a problem with the pressurized solution distribution system exists. The remote monitor is a status monitor only and does not include any controls that allow remote operation or adjustments of the PSDS system. A control and alarm panel houses the PSDS pump switches and system alarms. Bicarb mixing components. The inlet solenoid valve serves to control the supply of water for the mix tank and rinsing procedure. The flow meter valve and flow meter provide flow rate adjustments and flow rate readings in gallons per minute or liters per minute. The mix tank is a high purity polyethylene tank with a conical shaped bottom and molded volume markings. The mix tank is equipped with a spray head for rinsing and disinfecting internal surfaces. A sampling port is located at the bottom of the mix tank for testing and sampling purposes. A hinged cover with an O-ring seal is provided on the top of the mix tank for easy access and secure closure. A mix nozzle is located at the bottom of the mix tank to aid in the mixing of powdered bicarb. A carbon vent filter connected to the top of the mix tank and distribution tank inhibits dust or other debris from entering the system. A drain valve is provided to allow discharge of unused solution or rinse water. The mix pump provides for mixing of bicarbonate powder into solution and transfer of the mixed solution from the mix tank to the distribution tank. The mix pump is controlled with a timer that will shut down the pump after 10 minutes of operation to minimize the potential of overmixing. If more than 10 minutes of mixing is required, the hand switch will need to be turned to the off and back to mix to resume mixing. A flow switch is located on the output side of the mix pump. The flow switch prevents damage to the mix pump by automatically turning the mix pump off during insufficient flow situations. An audible alarm will also sound. The distribution tank is a high-purity polyethylene tank with a conical shaped bottom and molded volume markings. The distribution tank is equipped with a spray head for rinsing and disinfecting internal surfaces. The distribution tank includes float switches to communicate the high-level and low-level conditions to the PSDS controls. A jug fill valve is located near the bottom of the distribution tank for filling containers with mixed bicarb solution. A hinged cover with an O-ring seal is provided for easy access and secure closure. A carbon vent filter connected to the top of the distribution and mix tanks inhibits dust or other debris from entering. A valve is located near the return of the distribution loop to allow sampling of actual loop conditions. A drain valve is provided to allow discharge of unused solution or rinse water. The distribution pump provides for delivery of the bicarbonate solution from the distribution tank into and throughout the distribution loop. Marcor recommends that overpressure protection is installed at each point of use. The main power switch is located on the front of the control panel and must be turned to the on position to operate the PSDS. The mix pump switch is a 3-position switch that controls power to the pump and is used to mix the powdered bicarb in the mix tank and then to transfer the bicarb solution to the distribution tank. With the switch in the transfer position, the distribution tank high-level alarm and mix tank low-flow alarms are both engaged and either can stop the pump operation. The autofill mode timer is used along with the mix tank autofill switch and inlet water solenoid to fill the mix tank for a predetermined amount of time. The time setting will control the duration the inlet water solenoid opens to supply the mix tank with water. The timer mode must be set to the E and M for minutes settings with the user adjustable time settings. The mix tank autofill switch is a momentary switch that initiates automatic or manual filling of the mix tank. When the switch is moved to the start position, the fill timer and solenoid are activated, filling the mix tank for the duration set by the timer. When the switch is held in the manual position, the solenoid is activated, allowing water to flow into the mix tank as long as the switch remains held in this position. The flow meter scale allows visual settings between 0.5 and 5 gallons per minute. The autofill flow meter includes an integral needle valve to provide visual flow rate indication and adjustment. Set the autofill mode timer for the length of time needed in combination with the previously set fill rate to fill the mix tank to the identified water volume. For example, 3 gallons per minute times 20 minutes equals 60 gallons. Turn the mix tank autofill switch to the start position and release. The timer will blink on. Note, as the timer counts down, the display will be reduced from a full black bar to a dashed white bar, and off output will be shown when finished. The autofill mode timer may be canceled and reset at any time during the countdown period by turning the mix tank autofill switch to the start position. The alarm mute switch is a push-button switch that when pressed will silence the audible alarm. The alarm will not sound again if the alarm condition is removed during this period, with the exception of the distribution tank low-level alarm that does require the resetting of the distribution tank low-level hand switch. The distribution tank low-level alarm hand switch controls the function of the distribution tank low-level alarm. The alarm is enabled when the switch is in the on position. Moving the switch to the bypass reset position disables the alarm and illuminates the switch to provide additional user awareness of the alarm bypass. The distribution pump switch is a 2-position switch that controls power to the distribution pump. Moving the distribution pump switch to the on position initiates operation of the distribution pump and illuminates the distribution pump run light. Acid tank pump switch is a 2-position switch that controls power to the acid tank pump. Moving the acid tank pump switch to the on position initiates operation of the acid tank pump and illuminates the acid tank pump run light. up to 3 acids can be operated. The amber acid tank low-level light illuminates when a low-level condition in the associated acid tank occurs. Along with the tanks, pumps, and control switches, the PSDS incorporates valves that direct the flow of water, bicarb solution, and chemical disinfectant throughout the system. The valves are numbered V1 through V18, and the valves that will be opened or closed will depend on the specific procedure that is taking place. Valves 1 through 8 are primarily on the mixed tank side of the system, and valves 9 through 18 are on the distribution side of the system. Detailed step-by-step instructions for daily operation of the PSDS are included in Chapter 3, the System Operation chapter of the PSDS Operation and Maintenance Manual. There is one unnumbered valve in the system. This is the inlet water shutoff valve, and it's located under the plate right behind and underneath the front control panel. This valve is used to isolate the piping of the PSDS if the RO water loop, which feeds incoming water to the PSDS, is being disinfected using hot water. The PSDS is disinfected with chemical, and the plumbing components cannot withstand hot water disinfection. Note, the PSDS with the optional O3Z ozone disinfection system incorporates 4 added valves specific to the optional ozone disinfection system. Make sure that valve OZ3 remains in the open position and OZ1, OZ2, and OZ4 remain in the closed positions at all times except when operating the O3Z ozone generator. When opened, V1, the mix pump discharge valve, allows flow from the mix pump into the mix tank. When opened, V2, the mix tank spray head supply valve, allows flow from the mix pump to the mix tank spray head. The spray head delivers spray to cover internal portions of the mix tank. When opened, V3, the inlet water valve, allows RO water flow into the system. When opened, V4, the mix pump suction valve, allows for the mix tank solution to flow to the mix pump. When opened, V5, the mix tank drain valve, allows for draining of the mix tank. When opened, V6, the mix tank sample valve, allows for sampling of the solution in the mix tank. When opened, V7, the distribution tank fill valve, it allows for the transfer of solution from the mix tank to the distribution tank. When adjusted, V8, the adjustable inlet autofill flow meter, regulates the fill rate into the mix tank. When opened, V9, the distribution inlet valve, allows flow from the mix pump into the distribution tank. When opened, V10, the distribution spray head supply valve, allows flow from the mix pump to the distribution tank spray head. The spray head delivers spray to cover internal portions of the distribution tank. When opened, V11, the distribution pump suction valve, allows for the distribution tank solution to flow to the distribution pump. When opened, V13, the distribution flow control valve, allows for the solution to be pumped from the distribution pump to the distribution loop. When open, V14, the distribution return valve, allows for the solution returning from the distribution loop to either return to the distribution tank or be routed to the drain. When opened, V15, the bicarbonate supply valve, acts as a filling port for filling individual bicarb containers. When opened, V17, the distribution loop sample valve, acts as a sample port for the distribution tank. When opened, V18, the distribution tank drain valve, allows for draining of the distribution tank. The remote status monitor will notify users at a remote location of the system status and gives both visual and audible alarms. The PSDS status monitor communicates alarm conditions with the illumination of a red alarm indicator and the sounding of the audible alarm. It's also equipped with a temporary alarm mute button. Pressing the alarm mute switch on the PSDS status monitor will silence the audible alarm. If the alarm situation is not remedied, the system will re-alarm after 5 minutes. Monitoring logic and power are delivered from the PSDS controller through cable connections to the PSDS status monitor. Its compact size and optional mounting features allow it to be located near the dialysis area or nurse's station. The PSDS status monitor is available in either an external surface mount housing or flush mount panel with a variety of monitored features that include distribution pump and distribution tank low-level alarm status, acid tank levels, and alarm conditions. A mix pump low flow alarm condition is created when the solution velocity in the mix pump piping drops below 2 gallons per minute as measured at the flow switch on the output side of the mix pump. The mix pump hand switch must be in either the transfer or mix position, and the mix pump low flow switch not satisfied to activate the alarm. The mix pump shuts off in the absence of solution to prevent pump damage. The low flow condition is typically observed when the solution level in the mix tank empties while being transferred to the distribution tank. This is a normal occurrence and can be expected upon the initial daily transfer. An audible alarm sounds to prompt the user to reposition the mix pump hand switch and plumbing valves once transfer is stopped. When the mix pump hand switch on the PSDS is turned to the off position, the alarm will be discontinued. The alarm mute push button switch can be pressed to silence the audible alarm prior to switch and valve repositioning. A distribution tank high-level alarm condition is created when the solution level in the distribution tank rises to engage the high-level float switch. The mix pump hand switch must be in the transfer position and the distribution tank high-level float switch engaged to activate the alarm. The mix pump shuts off to prevent overfilling of the distribution tank. The alarm will be discontinued when the mix pump hand switch on the PSDS is turned to the off position. The PSDS status monitor communicates a high-level condition with the illumination of a red alarm indicator and the sounding of the audible alarm. Pressing the alarm mute switch on the PSDS status monitor will silence the audible alarm. A A distribution tank low-level alarm condition is created when the solution level in the distribution tank drops and activates the low-level float switch. The distribution tank low-level alarm hand switch must be in the on position and the distribution tank low-level float switch not satisfied to activate the alarm. The low-level condition is typically observed when the solution level in the distribution tank falls during use at the end of a treatment day or prior to the initial daily batch transfer from the mix tank. This alarm sounds when there is approximately 20 gallons of solution left in the distribution tank. An audible alarm sounds to prompt the user to recognize the low-level condition and take steps to replenish the distribution tank solution levels and/or disable the alarm. When the distribution tank low-level alarm hand switch is turned to the reset bypass position, the alarm will be discontinued. Pressing the alarm mute switch will silence the audible alarm for a period of 5 minutes. The alarms will not sound again if the alarm condition is removed during this period, with the exception of the distribution tank low-level alarm that does require the resetting of the distribution tank low-level hand switch. Multiple product options accommodate varying customer needs for distribution loop combinations, including single bicarbonate and up to 3 acidified concentrate solutions. The acid system operates using up to 3 acid solutions in bulk storage tanks. The tanks are fitted with low-level float switches to alarm and notify the operator when the acid level is getting low. Each bulk acid tank has its own pump to distribute the solution. While the acid pumps have a separate control box, they are wired into the main PSDS controller so they can be individually controlled from a single location. Wall-mounted solution dispensers are capable of delivering up to 3 different concentrates and water as well as drain access. Process connections are configured to be compatible with dialysis manufacturers' equipment. Heat disinfection only applies to the RO water inlet piping loop that feeds the PSDS unit. The PSDS system cannot be heat disinfected. If the PSDS unit is equipped with PVC loop flow piping, then it is not heat disinfect compatible. The PSDS unit must be equipped with PVDF loop flow piping in order to have this option. When performing RO loop piping heat disinfection, close the RO supply water shutoff valve to the PSDS unit. Detailed step-by-step instructions for daily operation of the PSDS are included in Chapter 3, the System Operation chapter of the PSDS Operation and Maintenance Manual. In this video, we will outline the basic operations of the PSDS. Daily startup will include ensuring that the various water valves are in their correct positions, that there is power to the PSDS, that the main power switch on the PSDS is on. Acid distribution startup verifies sufficient acid supply for the entire treatment day. Turn the appropriate acid tank hand switch to the on position to start the associated acid pump, and then verify the respective acid tank pump run light illuminates. This will start the distribution of acidified concentrate to the hemodialysis delivery systems. Warning: due to the possibility of disinfectant rebound, perform a residual disinfectant test before initiating the bicarb mixing procedure. The bicarb solution used by the hemodialysis delivery systems consists of a precise mixture of bicarbonate powder and AMI quality water. The operator will need to determine the amount of water that will be needed for the specific amount of bicarb solution that is being prepared. The bicarb powder manufacturer should have specific mixing volumes and instructions for the various formulations and size configurations of the bicarb concentrate. Warning: the inlet water valve V3 should be closed at all times except when the mix tank is being filled with water. The transfer valve V7 should remain closed at all times except when intentional transfer of solutions is to occur. If these valves are left open during treatments and the inlet solenoid valve fails, the bicarbonate solution will be diluted, causing interruption of treatment. To perform the mixed tank fill procedure, the operator will need to ensure that the valves are in the correct positions and the timer has been set for the correct time period to allow water to fill the mixed tank to the correct level. Adjusting the autofill flow rate and then setting and activating the autofill timer will fill the tank with water. The inlet water solenoid valve will automatically close when the timer reaches 0. Set the autofill flow rate between 0.5 to 5 gallons per minute. This rate will vary from facility to facility and will depend upon the amount of extra water produced by the RO after the demands of the hemodialysis delivery systems have been met. Once the fill rate has been established, the autofill time preset can be set to fill the tank to the approximate level needed for mixing the bicarb powder. Note: as the timer counts down, the display will be reduced from a full black bar to a dashed white bar, and off output will be shown when finished. The volume of water in the mix tank may need to be increased or decreased to be at the precise amount needed for mixing the bicarb powder. Turning the mix tank autofill switch to manual will open the inlet water solenoid valve and start to raise the level of the water in the tank. Or, opening V5, the drain valve on the mix tank can be used to lower the level of the water in the tank. Please read and follow all the bicarbonate powder manufacturer's instructions and labels regarding the preparation of bicarbonate solution before continuing with this procedure. Ensure the mix tank has been filled to the desired level and turn on the mix pump. Slowly add the appropriate amount of bicarb powder. Adding the powder to the water slowly will enable dissolving and mixing of the solution more efficiently. The mix pump will operate for a maximum of 10 minutes. If additional mixing is required, cycle the hand switch from mix to off and back to mix to restart the pump. Do not overmix the bicarb concentrate. Overmixing can cause CO2 loss and can increase the pH of the bicarb concentrate. Ensure the bicarb solution has been tested and is ready for use. The bicarb solution can be transferred to the distribution tank. To perform the bicarb transfer procedure, the operator will need to ensure that the valves are in the correct positions and the mix pump turned to the transfer position. An audible alarm sounds to prompt the user to reposition the mixed pump hand switch and plumbing valves once transfer is stopped. When the mixed pump hand switch on the PSDS is turned to the off position, the alarm will be discontinued. Ensure that the bicarb solution has been tested and is ready for use, and the distribution loop ports are ready for normal operation. The distribution pump will be used to pump the bicarb solution from the distribution tank to points of use in the bicarb loop. The end of the loop will return back to the distribution tank. The distribution tank does have a low-level alarm that will activate if the level of bicarb falls below the low-level switch. An adequate supply of bicarbonate solution must be constantly available during distribution operations. Refill the distribution tank from the mix tank as necessary and make additional batches of bicarb as necessary. Monitor the distribution tank level periodically throughout the day. An audible alarm will sound to alert the operator when the distribution tank is low. After the mix tank has been emptied, by transferring the previous batch of bicarb to the distribution tank, an additional batch of bicarb may be made. Before another batch can be prepared, the mix tank should be rinsed with AMI quality water to rinse out any residual bicarb. Since bicarb is typically only used for the day that it is made, the second batch may be smaller than the first batch, depending on the volume of bicarb concentrate needed for subsequent shifts. The operator will need to determine the amount of water that will be needed for the specific amount of bicarb solution that is being prepared. To perform the mixed tank fill procedure, the operator will need to ensure that the valves are in the correct positions and that the timer has been set for the correct time period to allow water to fill the mixed tank to the correct level needed for the second batch of bicarb concentrate. This will be a similar process to the first batch made. Prior to transferring a second batch of bicarb, the solution must be tested and verified as correct, per bicarb manufacturer's recommendations, before beginning transferring operations. Please read and follow all the bicarbonate powder manufacturer's instructions and labels regarding the preparation of bicarbonate solution before continuing with this procedure. Bicarbonate solution transfer can occur when the distribution tank level is low and the tank requires refilling. Transfer from the mixed tank to the distribution tank may be performed at any time during the patient treatment day. The bicarb solution in the mixed tank can then be transferred to the distribution tank. To perform the bicarb transfer procedure, the operator will need to ensure that the valves are in the correct positions and the mix pump turned to the transfer position. After completion of patient treatments, the system should be drained and rinsed with AMI quality water. The system should be disinfected or configured for the next day's operation, depending on facility protocol. Acid pumps may be shut down at this time also. Note: during the rinse-fill process, there are no alarms or overfill protection engaged. The operator must monitor the distribution tank as it fills. Warning: disinfection operations are recommended at the end of each treatment day. Label all wall dispenser stations and the PSDS with appropriate warning signs such as "Do not use, contains disinfectant." Dialysis equipment must not be connected to the PSDS during decalcifying and disinfection. Verify that all distribution points of use are disconnected. Wear gloves, eye protection, and protective clothing as required by your facility. Refer to the chemical manufacturer's safety recommendations. Caution: the PSDS and the distribution loop must be rinsed prior to disinfection, decalcifying. Reference the PSDS rinse procedure for instruction on system rinsing. Do not leave the PSDS unit unattended at this time. No alarm or pump protection is engaged at this time. Confirm the presence of the disinfectant decalcifier at all of the bicarbonate distribution loop ports during circulation. Use appropriate test methods to verify disinfectants. The disinfection decalcifying procedure consists of filling the mixed tank to a predetermined level, adding the disinfecting decalcifying chemical to the water in the mixed tank, and then circulating this through the mixed tank piping, and then transferring a portion of the chemical solution to the distribution tank. The chemical solution in the distribution tank will then be pumped through the distribution tank piping and bicarb distribution loop. After both tanks and associated piping have been exposed to the chemical for the proper circulation time, the chemical will be drained and a rinse procedure using AMI quality RO water must be completed. The PSDS has the option of ozone O3Z that converts ambient air to ozone. Ozone injection into water can eradicate all microorganisms and endotoxins. This ozonated water is suitable for disinfection and decalcification of the bicarbonate fluid path